Okay, so we've been using the word norm the last couple of videos, specifically in the context of L1 norm and L2 norm. The word norm is just a mathematical generalization of the notion of length or magnitude of a vector, right? So if you imagine a vector x with elements x1, x2, x3 till xn, or an array x, the L2 norm is your usual magnitude of the vector, right? It's square root of x1 square plus x2 square, etc., until xn square. Sometimes also called the Euclidean distance, magnitude of a vector, whatever, right? All those terms, you're very familiar with it. This is just called the L2 norm, okay? And it's called L2 because it's a square. And as we saw, L1 norm is similar to it, except there is no square and then there's no square root either. It's the sum of the absolute values of the elements. And then there is a generalization of these two things called LP norm, which is you raise each of the elements to the power p with an absolute value sign, and then raise that sum to the power 1 over p. And you can sort of verify that these two things are special cases of that. If you stick in p equals 2, you get this. If you stick in here p equals 1, you get this. And then, okay, so all these are essentially notions or generalizations of notion of distance, okay, for an n-dimensional vector. They're all positive and they all satisfy certain basic properties that you would expect things like distances to satisfy, specifically something called triangle inequality. Okay, so it's something you can look up if you want. In any case, so they behave like distances should behave or magnitudes of vectors should behave. Okay, there's a couple of more norms. One is called the L infinity norm, which is basically the maximum of all these elements. Okay, and if you think about it, you can sort of realize that if you raise um, each of the xi to a very, very large power, basically p tending to infinity, what will remain in the sum is the largest element. Right? So the largest element raised to the power p will so dominate the next largest element that when you take power 1 over p, what you get as the answer is basically the largest element of xi. Okay, so L infinity norm, it turns out, is just the maximum element with an absolute value sign. I should probably put an absolute value sign here, um, of all the elements in the vector. Okay, so that's called L infinity norm. There's something called the L0 norm, which people would say is not actually a norm. In other words, it doesn't satisfy the notions, the properties that norms should behave. But by convention, L0 norm is defined as the number of non-zero elements in an array like this or in a vector, right? So if you have a vector like this, you've got 1, 2, 3, 4, 5, 6, 7 elements total, and 5 of them are non-zero, right? 1, 2, 3, 4, 5. There are 5 non-zero elements, and it turns out that L0 norm is basically how many non-zero elements you have in your vector. Okay, so it turns out that in machine learning, people use all these things. This is the most common one, mean squared error, that you try to minimize. This one we try to minimize when we want to, when we feel like there are outliers, lots of outliers, or very large outliers perhaps. Um, and Things related to L infinity norm, it turns out, are used in robust control, sort of advanced control theory. Not exactly L infinity norm, but something related to L infinity norm. And then L0 norm is also used in machine learning, it turns out, when you want to increase what's called sparsity in a vector, right? So because it is trying to, it measures the number of non-zero elements, and you're trying to find a bunch of numbers, but you would like for most of them to be zero and only some of them to be non-zero, then you want to uh, essentially minimize the L0 norm of that vector because that minimizes the number of non-zero elements. Okay, and that's something that arises naturally in machine learning as well. Okay, so let me summarize by saying that mostly people do not use the LP norms except for p equals 0, 1, 2, and infinity. And really, people don't use 0, it turns out, because exactly, again, I'll talk about the technical details later. But 1, 2, and infinity are the most common. People sometimes want to minimize L0 norms, but it turns out that minimizing L1 norms is similar to minimizing L0 norms. So that's just a high-level overview of this notion of a norm. And like I said, just to recap, it's a generalization of length or magnitude, and um, in machine learning, very often we want to minimize these quantities. Okay, and it's good to know this language because if you're reading a textbook on machine learning, they might use this language. Okay.